Predicting when two elements will take part in ionic bonding. Using your knowledge of electronegativity, tell whether each of the following bonds will be ionic. Write 1 for ionic and 2 for not ionic. So we're going to take a look at these examples we have here and see which ones count as ionic and which ones do not. So H and H, H2, or in other words, H2. And H2 we know is a diatomic element, but notice when two elements are the same, they have the same exact electronegativity. So they're actually, when they're doing that, that means neither one of them is pulling an electron more than the other. So they are sharing electrons more than taking electrons, which is what ionic bonds do. So, or transferring electrons. So that means this is not ionic. So I'm going to put a 2 there. Cl and O, they're both nonmetals, and that means their electronegativities are pretty much really close. So 2 for that one. Na and F. Na is a metal, and F is a nonmetal. F has a high electronegativity, sort of like Cl, and we know the common example of NaCl is salt, and that is an ionic bond. So Na and F would be a good bet that we're also going to have an ionic bond because Na is a metal and F is a nonmetal, and their electronegativities are very far apart. So we have a 1 here for ionic. C and N. C and N are both nonmetals and have similar electronegativities since they're so close together in the periodic table. So that means that I'm going to give that a 2. CS, cesium. It's also one of the alkali metals, so it's very reactive because it wants to give up one of its electrons. And F really wants an electron, so this is also an example of an ionic bond because there's a transferring of electrons or taking of electrons, if you prefer. And CS is metal and F is a nonmetal, so I'm going to count that as an ionic bond, ionic bonding. And F, zinc, Zn, and Cl. Zinc is another metal. It's a transition metal, but it is a metal that has a higher electronegativity, has a low electronegativity and wants to give up its electrons to the high electronegative Cl. So I'm going to count that as ionic. So we have C, E, and F all being ionic bonds because there is a transfer of electrons, transfer, you can also see taking of electrons, and it happens between a metal and a nonmetal with very different electronegativities.